Alright guys, so today we're going to do something new, and I am going to use this lovely, awesome, let's see if I can get it, there we go, this document camera to take our notes. So last week we talked a lot on these inequalities, about inequalities, how we can graph them, how we can do interval notation with them, and why it's important for us to be able to determine if the circle's opened or closed, right? So we've done that. We've talked about interval notation, which is all over here, right? With the negative infinity, positive infinity. These were some of the things we discussed last week. So 1/6 builds off of this idea, and 1/6 is on compound inequalities. So a compound inequality, there's two things you need to know about compound inequalities. The main things are these ands and ors. So if I relate this to our personal life by saying, hey, maybe I can go to the store and I can get milk. And get milk. Notice how I use the word and in there. I can do two things at once. I can go to the store and I can get the milk at the store. Okay, usually and problems do not have the word and in them, all right, which we'll go over in a minute. And means an intersection. All right, it can be seen with that nice little N, I call it. It means both things are true. Again, I can go to the store and I can get milk. All right. The second term is or. So I can go to the store or I can go to my friend's house. All right. So that uses the word or. That determines that there's a union there. You can see the U. That's how I remember it. This one has a upside down N or an N. This one has a U for union. That means either are true. Not both, but either one can be true. All right, you will always see the word for or in the problems. So down below, solve each, include both a graph and interval notation. All right, so this is what we were doing last week. But now we have two inequality signs. Same thing, pretend like there are equal signs here. All right, we want to get the variable by itself. So what I'm going to do here is I'm going to add 9. I'm going to go ahead and add 9 to both sides. All right, so -5 plus 9, well, that's going to give me 4. I'll bring down my symbol. All right, I'll bring down my x, and I'll bring down my 19. All right, this is my solution. What this is saying, this is a and problem, okay? So it says add to both sides. We know it's an and problem because it doesn't have the word or in it, all right? So what this is saying is x is going to be greater than 4 and x is going to be less than 19, all right? So after we've added to both sides, we know this is an and problem. Both are going to be true. So find your 0, all right? Find your 4. Ooh, sorry. Find your 19. All right, for this inequality, is my circle open or closed? Well, it's open at 4. It's going to the right. All right, we have a circle at 19. It's going to the left. So all of these numbers from 4 to 19, right, does not include 4, does not include 19 because they're not shaded in. But all these numbers here make the statement true. Okay, so we're going to go ahead and we are going to go ahead and do our interval notation. The lowest it can possibly be is going to be close to 4, but does not hit 4 because it's not shaded. It does not include 4. All right, the highest it can be is 19, and we're going to do a parentheses because it does not hit 19. All right, so any numbers in here make the statement true. All right, let's try this next one. This one is going to be an or. All right, so again, we're going to solve these as two separate inequalities. So for this first one, I'm going to divide by 4. Divide by 4. You get x is greater than or equal to -3. Or, we're going to solve this one. I'm going to subtract my 3. Subtract my 3. We get x is less than -10. All right, so we have our or. Now, for ors, there will not be an overlap. Where here they overlapped, right? There's not going to be an overlap for this one, so it's really easy to see, all right? So let's go ahead and do this. For x is greater than or equal to negative 3. I'm going to go ahead and indicate that there. Is my circle opened or closed? Well, it's going to be closed, and it's going to the right. All right. The next one, x is going to be less than negative 10. Again, it's an or, going the opposite way. There's no line underneath, so it does not hit that. So you might be saying, okay, well then what do I do for interval notation? Well, we want to start all the way to the left. What is the smallest number it can possibly be? Well, negative infinity. The highest number it can hit here is going to be at negative 10, or get close to, not hit. Okay. Now, I'm going to do this union sign to say that, okay, well, it could be from negative infinity to negative 10, or, this says or, it could hit at negative 3, and it could go to positive infinity. So notice how I used this union, okay, to say either of these statements are true. Either of these will make this statement true for these inequalities. All right. No overlap, so you'll see that. This one has the overlap, so it's an and. This one's an or. Let's go ahead and try this next one. This one says and. So we know there's probably going to be an overlap. Let's go ahead and solve. So I'm going to add 6 and add 6. We get x is less than 11. And I'm going to add 4, x is greater than 6. All right, let's go in and graph. 0, 6, 11. X can be less than 11, or x can be greater than 6. All right, so interval notation. For this one, the smallest it can be, since we overlapped this, is going to be 6, does not hit, and then up to 11. So that's why I'm doing the parentheses. This indicates there's an and because of the overlap. All right. I'm going to have you guys go ahead and try number 4 on your own. It is an or. All right, and then I'm going to also have you do number 5 on your own. Hint, hint for this one, think about what we talked about yesterday or last week. If I divide by a negative number, what do I have to do to my symbol here? And then if I divide by a negative number, what do I have to do to my symbol there? That should get you guys started. We'll go over these tomorrow. All right, next page. This page says the sum, which is an addition problem, an answer to an addition problem, of 3 times a number and 4 is between negative 8 and 10. Okay, so let's figure this out. They're saying 3 times a number. All right, the sum of 3 times a number plus 4 is between negative 8 and 10. Which means it has to be less than 10. And what did we learn about the other day with between? Well, if we have something between, our arrows or our inequality signs are going to go the same way. So the sum of 3 times the number plus 4 is in between 8 and 10. So we have to figure out what that is. We're going to go ahead and solve. I want to get my variable by itself in the middle. Subtract 4 from both sides. We get 4 is less than 3n, which is less than, oh my gosh, sorry. It says negative 8. Negative 12 is less than 3n, which is less than 6. All right. When I do that, divide everything by 3. And I'm going to go ahead and rewrite this over here. So I get negative 4 is less than n, which is less than 2. Okay, if I break this apart, this is really saying, okay, that n is less than 2, but then n is greater than negative 4 when I flip that part of the symbol so that the variable comes first. Okay, let's graph. I have 0. All right, I'm going to have negative 4, and I'm going to have 2. Well, we know this one's going to be an open circle. It's less than 2. This one, open circle, greater than negative 4. So this is going to be an and, right? Because there's the overlap. What do you think we're going to do for interval notation? Well, all the way to the left, the smallest it can get is close to negative 4, but it does not hit. Greatest it can be is 2, does not hit. So that's saying any number from almost negative 4 to almost 2 will make this statement up here true. All right, let's try this next one. 5 times a number is less than 26, or, that's a big word, 6 plus that same number is more than 30. Okay, so that or indicates that there's no overlap. So 5 times a number is less than 20, or 6 plus that same number is greater than 30. Go ahead and walk yourself through this. I know n would have to be less than 4 because we're dividing by 5 on both sides. Or, if I subtract 6 on both sides, n has to be greater than 24. Okay? 0, 4, 24. Open or closed? Open. N has to be less than 4, or open, n has to be greater than 24. Go ahead and freeze your screen. Try that interval notation on your own. Freeze it, and then check and see if you did the same thing I did. I know for this one, for interval notation, the lowest it can get is negative infinity. The highest it can get is super close to 4, but it does not hit. Okay, or the smallest this one could be is close to 24. The highest it could get is to positive infinity. All right, down below, these are easy. Name each graph. All right, this is an inequality, which means that you're going to have a number, a symbol, sorry, I lied, a variable, a symbol, and then the number. So for this one, I'm going to say x, closed circle, it's greater than or equal to 8. Go ahead and try these next two on your own. Freeze the screen and then see if you did the same that I did here. For this one, I'm going to say j is less than negative 13. This one, k is less than or equal to 3. All right, so these are compound inequalities. It's building off of the inequalities we had from before. If you have arrows going two separate ways, it's going to use or. If there's an overlap, we have and. Same thing with interval notation as last time. Circles, if they're shaded, it includes that number. If they're not, it does not include that number. So that is a little bit on 1/6 compound inequalities.